onset of cancer usually begins as a solitary tumor in a specific area of the body. If the tumor is not removed, cancer has the ability to spread to nearby organs, as well as places far away from the origin, such as the brain. So how does cancer move to new areas, and why are some organs more likely to get infected than others? The process of cancer spreading across the body is known as metastasis. It begins when cancer cells from the initial tumor invade nearby normal tissue. As the cells proliferate, they spread via one of the three common routes of metastasis: transcoelomic, lymphatic, or hematogenous spread. In transcoelomic spread, malignant cells penetrate the covering surfaces of cavities in our body. These surfaces are known as peritoneum and serve as walls to segment the body cavity. Malignant cells in ovarian cancer, for example, spread through peritoneum, which connects the ovary to the liver, resulting in metastasis on the liver surface. Next, cancerous cells invade blood vessels when they undergo hematogenous spread. As there are blood vessels almost everywhere in the body, malignant cells utilize this to reach more distant parts of the body. Finally, lymphatic spread occurs when the cancer invades the lymph nodes and travels to other parts of the body via the lymphatic system. As this system drains many parts of the body, it also provides a large network for the cancer. In addition, the lymphatic vessels empty into the blood circulation, allowing the malignant cells to undergo hematogenous spread. Once at a new site, the cells once again undergo proliferation and form small tumors known as micrometastases. These small tumors then grow into full-fledged tumors and complete the metastatic process. Different cancers have been known to have specific sites of metastasis. For example, prostate cancer commonly metastasizes to the bone, while colon cancer metastasizes to the liver. Various theories have been proposed to explain the migration pattern of malignant cells. Of particular interest are two conflicting theories. Stephen Paget, an English surgeon, came up with the seed and soil theory of metastasis. The seed and soil theory stated that cancer cells die easily in the wrong microenvironment. Hence, they only metastasize to a location with similar characteristics. However, James Ewing, the first professor of pathology at Cornell University, challenged the seed and soil theory and proposed that the site of metastasis was determined by the location of the vascular and lymphatic channels which drain the primary tumor. Patients with primary tumors that were drained by vessels leading to the lung would eventually develop lung metastases. Today, we know that both theories contain valuable truths, yet the full story of metastasis is much more complicated than either of the two proposed theories. Factors like the cancer cell's properties and the effectiveness of the immune system in eliminating the cancer cells also play a role in determining the success of metastasis. Unfortunately, many questions about metastasis remain unanswered till today. Understanding the exact mechanism holds an important key to finding a cure for advanced stage cancers. By studying both the genetic and environmental factors which contribute to successful metastasis, we can pinpoint ways to shut down the process. The war against cancer is a constant struggle, and scientists are hard at work developing new methods against metastasis. Of recent interest is immunotherapy, a modality which involves harnessing the power of the immune system to destroy the migrating cells. This can be done in different ways, such as training immune cells to recognize cancerous cells via vaccines. The growth and activity of the immune cells can also be stimulated by injecting man-made interleukins, chemicals which are usually secreted by the immune cells of the body. These two treatments are only the tip of the iceberg. With the collaborated research efforts of governments, companies, and scientists, perhaps the process of metastasis will be stopped for good.